All right, starting off this next video, we're going to look at step 5, which is to add the half reactions and cancel. Cancel things, of course, that we can. So I'm going to take these guys, and again, I'm going to kind of just like build out from the middle. So I'll start off putting in an arrow and add in the elements. And you can put them in any order you want. There really is no magic to this. Don't forget 2 this time. Now, actually, I'm going to hold off here before I add in all these. Yeah, I will hold off. I was debating whether I want to put them in or not. I will bring this down so we can see the whole thing. So I'm not going to write more than I need to. When I look at these two equations and how I balance them out, I have 6 hydrogens here on the right and 14 here on the left. You could do it either way. I can write them in and then cancel them that way, or I can do it right now. I'm going to do it right now. If these 6 go away from both sides, I'm left with a total of 8 hydrogens. Fair enough. And then the next one I'm going to go on to, so I'm of course not going to write those hydrogens on the side, which is why I'm doing this, so I can limit the amount of stuff I'm writing. I've got 3 waters and I've got 7 here, so I'll be left with a total of 4 waters. And sometimes you can go either way on this. Typically I will write them in so I can see the exchange. 6 electrons, 6 electrons. It happens to be balanced. Let me mention this point right now. If they are not balanced, well, they have to be. In other words, you can't have 4 electrons here and 2 over there. That doesn't make sense. They have to add up, showing that there's 6 electrons being lost over here, or excuse me, gained over here and lost over on this side on the right. So if they're not equal, say for example I have 2 here and 3 here, then I would multiply this entire line by 3, everything, to get it to 6. And then if this was a 3, I'd multiply this entire line by 2 to get it to 6. There you have it. This whole process is done. We did it. It's all balanced out. And if you want to see how these guys kind of just figured in here, we can look and see who gained and lost electrons along the way. Of course, we can see how that played out here as far as gaining and losing electrons for chromium and iodine. But let's take a look at it individually. Iodine here is a positive, or excuse me, a -1, and iodine here, based upon the charges, this iodine is actually a +5, because this is -2 that we saw with these rules based on the charges. And there's also some understanding that we would have learned a little bit earlier in the year. I believe it's in chapter 3 or 4. But it's coming back into play. You can review this in some of the PowerPoints. I'm not going to dig into it now. It would take too long. But if this is -2 for oxygen, therefore -6, but -1 total, so therefore this must be +5. So in order for this to have happened, we went from -1 to +5, so we lost 6 negative electrons for that to take place. And then when I look at dichromate, or chromium in particular, going from this stage here, so this is -14. So -14 to -2 means it has to be +12. But +12, and there's 2 of them, so therefore it's +6 each. And these are +3 each. So if these are +3 each, therefore it gained 3 electrons each for this to take place. And again, as far as the process, this gaining electrons is called reduction. Sounds like opposite. So this is reduction, or it's being reduced, and this is being oxidized. I can probably anticipate this a lot. This is a lot of information. It's probably a little bit confusing. you're going to want to either pause it, go back and relearn this, or of course ask questions as you have them. Now, this process we just did works fantastic when you are in an acidic solution. And that's what we are here. This is an acidic solution with hydrogens present. But what happens if you're in a basic solution? It can happen. So in basic solutions, let's do it. We have some permanganate with some bromide, producing some manganese oxide and some bromate. For this, again, we're going to do the exact same process. I'm not going to write down all these rules, but we'll do these all individually. First one I'm going to take a look at here is the manganese compound. So that's one of our groupings. And I'll go ahead and just fire through this whole process as far as adding water and oxygen along the way. Okay, so to get the oxygens to balance out, I'm going to add water. And for this first one here, I'm going to add 2 waters. Give myself those 2 oxygens. In the process, I added 4 hydrogens. I'm going to balance those out. 4 H pluses. But I said this needs to be in a basic solution. So this is going to be the first example that we're going to see this change. If this needs to be in a basic solution, I'm going to neutralize all of these hydrogen ions with equal amounts of hydroxide ions. Now in doing so, whoops, oh boy. In doing so with that, I have to put an equal amount in here, and of course that is not an equal amount. So if I have 4, I need to have 4. Sometimes I struggle with the math. Is that part balanced out? But I have to do it to both sides. You can't just simply add one part to one side, unless it's something, of course, that's aqueous. But if I'm adding 4 hydroxides to this side, I have to add 4 hydroxides to that side to balance out the oxygens and the hydrogens. Okay, this last part here, I can look at for the electrons. For the electrons, to make sure this works out here, how many electrons do I have going on here to start with? This side I have -1, positive, well, these guys cancel each other out, so that's not it. So -1, done. And this side I have -4. So -1 plus 3 electrons. That's done. All right, let's look at the other part, the bromine. Bromine, -1, and it turns into bromate. All right, same process here. I need to balance out the oxygens. So 3 waters. That messes up my hydrogens. So 6 hydrogens. And then as far as charge, I am -1 and +5. So +5 needs to come down to -1. So I'm going to add 6 electrons. There we have it. All right, so now I need to balance this whole thing out. Oh, shoot, I forgot something. If only we were in class, you could yell at me. Let me hold off on the electron things for a second, and I'll fix this. Okay, so this needs to be in a basic solution. So, okay, I added those here, add those here, and that part's fine. Let's try this whole thing again. I think it's still going to work out to be exactly the same because that didn't charge everything here, but let's find out. -7 and -1, so I need 6 electrons still because we had the same thing. It didn't change anything. This gives us that example that we had previously that we need to balance. I have 3 electrons here and I have 6 electrons there, so therefore I'm going to multiply this entire line by 2. So everything in here is this is gonna get messy. So hopefully you've got an eraser handy. This becomes 6. This becomes 8. This becomes 8. This becomes 2. This is 2. This is 4. And this is 8. Okay, so I can ignore all these numbers. I'm just going to cross them off so I know I've dealt with them. Now, I have to balance these numbers in here. Remember that this is 6 waters, so I'm going to put these guys together and say 6 H2Os. And I got the same thing going on up here. This is 8 H2Os. But I also have some more water over here. So I have 4 and 8, so these are gone. And again, as I said, this is going to get messy. And that leaves me, if I get rid of these 4, now I have 4 of these left over. Going back down to here, for this one here, I have these 6 and these 3, and this is down to 3. So now as far as how many I have total left over, all of these are gone. And this is now just down to 1. Okay, so I have 1 water. Now other things we can take a look at are the hydroxides. I have 6 hydroxides here, and I have 8 hydroxides there, so all of these are gone, and I'm down to 2. Now at this point, I can go ahead and just add up the whole thing, because the other ones I don't believe were affected. So same process, I'm going to put the arrow in, and then just build out. So I should have 2 permanganates and 2 manganese oxides. Then I'm going to look for the bromide, excuse me. That's taken care of. Now I got to figure out who's left here. In this line here, I had 1 water, it looks. Anybody else? Looks like I got everyone over here. And then in this one here, as far as what I had left over, 2 hydroxides. And then as far as the electrons go, I had 6 electrons. So this one's a little bit more complicated. All right, it's a lot more complicated. So you'll probably want to run through this one and have really good organizational skills. And if you do, keep trying. It should come to you, and so again, just like the other one, we can talk about any problems you're having in class.